Okay, so on this lesson, we're going to be going back to transformations. Remember, we discussed that briefly in Unit 1 when we were talking about all the different parent functions. So today we're going to be focusing on 3 different types of functions, which we've already kind of covered, but we're going to throw in tomorrow some composite functions, which we'll look at. So we're going to review this a little bit. So the most basic, if you're looking at this graph here, this is your square root function, which is f of x equals square root of x. That's your parent function. That's what it looks like on the graph. So the square root functions are a subset of radical functions. Of course, we've talked about a radical before, square root, cube root, and so on. They have an endpoint and extend indefinitely in one direction. So that's what it looks like over here on this graph. Okay, so the next one we're going to be looking at is this graph, which is the cubic function. The most basic of the cubic is your parent function, f of x equals x cubed. And the cubic functions are a subset of a polynomial function, and the ends extend indefinitely in opposite directions, which is what we see over here on that graph. Okay, so the third one we're going to be looking at, here's our graph. This is the cube root function. So the parent function of that, which is your basic, is cube root of x. So the cube root functions are a subset of radical functions, just like up at the top with the square root. And the ends extend indefinitely in opposite directions. Anytime it extends indefinitely in opposite directions, like the last two that we looked at, your domain and range will always be all real numbers or negative infinity to infinity. So every single time, we're all real numbers. Okay, so let's look at a couple of examples. So we're going to use the given information to complete the chart. So we're given this table with x values, we're given the parent function, and then we're going to graph it, find the domain and range. So we are given an x value and we're going to substitute it in. The square root of -4, that is not able to graph because that would be an imaginary number. So you would just write undefined here. Plugging in -1, same thing. Square root of -1 would be imaginary. Plugging in a 0, square root of 0 is 0. Plugging in a 1, square root of 1 is 1. Plug in a 4, square root of 4 is 2. So I'm going to plot those points. When it's undefined, that means there's not a point. When x is -4, there's not a y value, so we won't be plotting those. Okay, so let's plot 0, 0. That means it stops because at -1 it's undefined. 1, 1, and 4, 2. And remember we said on the square root it keeps going. So looking at domain, so look at the x-axis. You can either use set notation or interval, I don't really care. So my smallest x value is 0, and then it's going to positive infinity. It does include 0, so a bracket and then a parenthesis next to your infinity sign. Or you could put x is greater than or equal to 0, so your choice. The range, if you look at the y-axis, go to the bottom, it's at 0, and then it keeps going up, so infinity. It includes 0, or you could put y is greater than or equal to 0. So that's the square root parent function. Now let's look at the cubic. So we're going to plug in some points. Here we're given the x values again, so we're going to substitute it in. -2 cubed, which it means -2 times a -2 times a -2 is a -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. So let's plot those points. And then it could keep going both directions. So remember what I told you, that if your both ends go opposite directions, your domain and range is negative infinity to infinity, or all real numbers. I don't care which way you write it. Okay, so looking at our third one, cube root. So plug in a -8. Now, on the square root one, we weren't able to have negatives because we can't figure out a number multiplied by itself that gives us a negative. Okay, so we can, however, take the cube root of a negative number. So cube root of -8 is -2, because a -2 times a -2 times a -2 is a -8. Cube root of -1 is a -1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. So let's plot those. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So again, if both ends are going opposite directions infinitely, remember your domain and range will always be all real numbers, or negative infinity to infinity. Okay, let's take a look back. So these are a great resource for you to use to remember all of the different transformation rules that we've already talked about. So anytime you're struggling with that, just look at this chart here and that will be helpful. So we're going to be writing equations from descriptions. So again, this part should be a review. We've already talked about it. So we're going to write the equation G that results from the transformations. So we're going to shift f of x equals x cubed up 7 units. So I'm writing function G because that's what it told me to put. If you go up, remember that is a vertical shift. So I'm going to go ahead and write x cubed, which is my parent function, and I'm going to shift it up 7, which would just be a plus 7 on the outside. And then part B, so this is a horizontal stretching. Remember we talked about this again in the unit at the very beginning. Horizontal is always the inside, which is always adjusting your x. So I'm going to put inside. And it's always the opposite. So it's a horizontal stretch by a factor of 2. So I'm writing my function G. I have to use my parent function. Since it's horizontally stretching, I do the opposite of 2, which is 1/2, and then I put the x. So that would be my new equation G. So remember, horizontally is inside and always the opposite. Okay, so now we're going to be reflecting about the y-axis. Anytime you reflect about the y-axis, if you look at that chart there, it's on the inside. So it's the opposite. So it just makes that x on the inside negative. Okay, so looking at the next one, we're reflecting the cube root of x about the x-axis. So the x-axis reflection is on the outside. So we'll have function G, we'll have a negative on the outside, and then take the cube root of x. Okay, so this next one, we have f of x equals square root of x. We're going left 5, so anytime we're doing a horizontal shift, that's on the inside, and it's always the opposite. So in the inside, instead of going, you would think minus 5 because it's going left, but really you're going to be doing the opposite, and you're going to be adding 5. Okay, and then this last one, vertically stretching, that's always on the outside vertical, and it's whatever you see there. So we're going to do a vertical stretch by 5/2. So g of x equals 5/2 x cubed. Okay, let's take a look at the next page. So on the back, we're going to be given a graph F and a graph G on the same grid, and we're going to describe the transformations, and then we're going to put it in function notation description and also the equation. So your F is going to be the parent function, so you have to recognize what parent function it is. So if you look at function F here, this is square root. And notice that that F function has been reflected over the y-axis. And so your function notation description means you're using your function f. And then anytime it's reflected over the y, it's the opposite inside, so it'd be negative x. So instead of putting f of x, which is your parent function, you're adjusting that based on your transformations. The equation for that would be square root of negative x. Okay, so looking at the next one, so your f is your original, so f is your parent function. Notice that is cube root graph. Notice it went up 1, 2, 3. So your function notation, you're leaving it with f of x, which is your original, but you're going up 3 with it, so it would be on the outside, so the plus 3. The equation, you're using g, and we're doing the parent function, cube root of x, and we're adding 3 to the outside of the radical. Next one, looking at f. That is the cubic. And notice it went to the right, 1, 2, 3, 4. So we're using our function notation, f of x is our original. We're going right 4, so remember that's the inside, and it's always the opposite, so it should be an x minus 4 inside. The equation for that, that's cubic. So it would be x in parentheses, x minus 4, and then the cubed on the outside. That's what that would look like. So different ways of identifying your transformations from your graph. Okay, so last example, we're going to be looking at multiple representations. So we're going to be given something, given some information, and we're going to have to fill in the rest of the chart. So looking at this first one, the original equation f of x equals square root of x, and we're given a new graph. Okay, so we need to look at this graph here because we're going to write the transformed equation. So notice normally the square root graph is here. Remember the points that we had were 0, 0, 1, 1, and then 4, 2, and 9, 3. So those are our normal points. Notice the graph shifted up 2. I'm going to go ahead and write up 2. That'll be easier for us. We're going to write the transformed equation. So g of x. We're going to have square root of x, and it went up 2, so plus 2 on the outside. Excuse me. Your function notation, which means just leave with f of x, which is your original, and we added 2 to it. Okay, so your original function, so I went ahead and graphed it. Our original domain and range, we already talked about it, but we'll go ahead and go over it again. Domain, it goes from 0 to infinity. And same for the range. Now, looking at this transformed one, it went up. So the domain is still the same because it didn't shift left or right. So 0 to infinity. And then your range, however, went up 2. So instead of your smallest being 0, it's going to be at 2 and then infinity. So notice our range changed because we were adjusting our y. We were changing the y. It was a vertical shift. Okay, let's look at the next one. Okay, so this one we have the cubic, x cubed graph. And we are given, instead of the graph this time, we're given the function notation description. So the negative in front means it's a reflection over the x-axis. So I'm going to go ahead and, so I'll write reflects over x. I'm going to go ahead and fill in my parent function. So you need to know those. So that was, let's see, we plugged in a -2 and we got -8, -1, -1. 0, 0, 1, 1, and 2, 8. So this is my original. It helps if you graph that also. And I'm going to reflect it over the x-axis. So my 0, 0 point is not changing. So when now we reflect over the x-axis, that changes y value because you're reflecting over the x-axis. So this point comes here, this point goes here. Go back. So it's changing the sign of your original y value on your parent function. So let's find the domain and the range. Domain, we're looking first at the original, which is the purple. So domain is, remember we said, when both ends are going opposite direction, negative infinity to infinity, or all real numbers. And then same exact thing for the reflection. Now, I skipped a few things up at the top, one thing. So we still need to go back up here and write our transformed equation. So g of x equals negative x cubed. Okay, last one. So notice this one is cube root, and notice we're given the new function. So if there is a number on the outside in front, directly in front of your parent function, that's going to be either a vertical stretch or a vertical compression based on the number. It's greater than 1, so this is a vertical stretch by 2. And then our function notation description would be f of x, and then we're just putting a 2 in front of it. So again, it's very helpful if you go ahead and graph your parent function, and then you can graph the new function. So if you remember, we plugged in -8, and we got -2. -1, -1, 0, 0, 1, 1, and 8, 2. So this is what our parent function looks like. We're stretching it by 2. So on the outside, you're always adjusting your y. So we're going to need to leave our 0, 0 point. But instead of our point being 1, 1, we would multiply our y by 2. So write 1 up 2. Write 8 instead of up 2, up 4. So it's stretching those values by 2. So multiply y by 2. So you're multiplying your original y's by 2. All right, so domain, notice both ends are going opposite directions, so negative infinity to infinity on both, domain and range. And then your new graph, same exact thing. Or you can write all real numbers. If you have any questions, please let me know.